Okay, so we're going to start talking about section 4.1. 4.1 is an introduction to what are called rational functions. And a rational function has the following form. A rational function is of the form r of x equals p of x divided by q of x, where p of x and q of x are polynomials. So we're extending this idea of polynomials, and now we're making fractions, ratios, rational functions out of polynomials. So a simple example might be something like r of x is equal to x plus 1 over x squared minus 4. This is p of x. This is q of x. This is the numerator. This is the denominator. And the simplest rational functions are negative powers of x, negative integer powers of x. So r of x equals x to the negative 1, or 1 over x. And if you've never seen that before, we'll do a little drawing of it here. See, this will be 1, 1, negative 1, negative 1. And the first thing that we might want to notice is domain issues. This is undefined. Undefined if x equals 0. And if x is close to 0, though, we're going to have a fraction with a really small denominator, which is going to be a very large value. So what we end up with here is what's called a vertical asymptote at x equals 0. As far as the end behavior goes, as x becomes very large, r of x has specific behavior. So I don't know what you guys know about fractions, but if you make the denominator large, the fraction gets small. And the larger the denominator gets, the smaller the fraction gets. And this tends towards 0. Also, as x approaches negative infinity, even though you have, so 1 over infinity is tending towards 0. Those aren't actually equal, but we think of them that way. And 1 over negative infinity is also a very small number. So this is the idea that 1 over large equals small is a way of expressing that. And this is r of x also approaches 0. So what we get here is, as we tend towards larger and larger values in both the negative and positive direction, we get closer and closer to 0. And we get what's called a horizontal asymptote at y equals 0. So this is a vertical asymptote. This is a horizontal asymptote. And let's see, when we plug in 1, we get 1 over 1, which is 1. When we plug in negative 1, we get 1 over negative 1, which is negative 1. And then as we plug in larger and larger values, this tends to get smaller and smaller and smaller. And as we plug in larger and larger negative values, this also gets closer and closer to 0. But as we plug in numbers that are close to 0, right, like 1 over 0.1 is 10, and 1 over 0.01 is 100, and 1 over 0.001 is 1,000. You might use this same notation to say something like this. As x approaches 0 with a little positive sign, this means approaches 0 using x values larger than 0, then we can say r of x approaches infinity. That is to say, as we get smaller and smaller values in the denominator that are positive, r of x tends to grow. And as we get closer and closer to x equals 0, this gets larger and larger and larger, and eventually becomes infinitely large. Similarly, for 1 over negative 0.1, which is negative 10, 1 over negative 0.01, which is negative 100, and 1 over negative 0.001, which is negative 1,000. As x approaches 0 from the left side, or using values that are less than 0, r of x approaches negative infinity. So this is using values less than 0. And so as we approach 0 from the left side, these become larger and larger negative values, and we get this split behavior. And this is the graph of 1 over x. Now, if I copy this, duplicate, oops, duplicate. No, stop it. So this blue curve was 1 over x. And in a very similar way like x squared and x cubed, as the power goes up, 1 over x cubed is similar. Sorry, let's go to 1 over x squared. 1 over x squared is similar, but if x is less than 0, 1 over x squared is greater than 0, and it has slightly different behavior. It actually goes through the same points. It has the same asymptotes, but it is a little farther away from the axis here and a little closer to the axis here. And this curvature becomes more pronounced. However, this one is also positive on both sides. So that's 1 over x squared. And as the power goes up, this isn't too terribly important, but as the power goes up, it becomes more pronounced. This corner becomes steeper. And of course, if it's odd, it can be negative. And the curvature gets a little bit crazier and crazier. So 1 over x cubed is steeper with more pronounced corners, and can be positive or negative in the outputs. Anyway, those are the basics of a simple rational function, but we're going to be looking at more complicated curves than this. And eventually we're going to learn how to graph them.